Okay, recording now. Okay, so you have some stuff due today, right? What am I doing with my homework pages? Nope. Don't forget you got some reading stuff out there. GeoGebra is due on Tuesday, that intro lab. Some of you have already started showing it to me, asking me questions, that kind of thing, so hopefully that's going well. And then pages 259, 263, 271, which are not those pages at all. It's 5.1, 5.2, and 5.3 if you have the other book, okay? So it's all about polygons and stuff like that. Actually, I think 5.1 is external, maybe exterior angles of a polygon, something like that. So I think 5.3 is kites and trapezoids. So anyway, so those get us kind of caught up on most of the stuff we've been doing. And then we started working on proofs the other day. So we're going to pick up there. But don't forget that this stuff is outstanding. It's out there, running around, wanting to be done. A real quick point, a couple of people have pointed out, all three of those homeworks go in the 259 folder. So yes, there's only one folder open. There are 3 of them, but because they were all assigned at the same time, just turn them all in the same folder. They don't have to be a single file. It can be a separate for each assignment, but one folder will hold more than one assignment, which is awesome. All right, a real quick note I made for myself about the triangle quiz. A couple of you had asked me questions about it. The question that got some of you that you weren't sure about, let me go ahead and do that one. We actually did it in class. It was the one where we had a triangle inside of a triangle. Like we literally did this one in class. And I think we knew that this was supposed to be isosceles, right? Something like that on the picture. So the answer that I was looking for was something along the lines of, these are similar triangles, so their base angles should be the same. However, some of you did, for instance, if you had gotten 74 and 74 and figured out what this top angle was, then you said, well, this angle in here doesn't add up to 180. So some of you clicked on the triangle doesn't add up to 180. So the D2L counted it wrong because that wasn't the answer that I gave it. But I went back and looked, and if you gave me that, so I took either answer basically. So if you gave me that the triangle didn't add up to 180, I was okay with that. Or if you did the similar triangles have to have the same base angles, I was okay with that. So you should see that your grade has been updated in D2L because I did that last night just to make sure. So that's all done. Grades are going in this week and over the weekend, so hopefully you have homework grades by next week whenever we get to class. Yes, Demandre, you can submit more than one thing into each folder. So like 259, you can have one file for 259, one file for 263, and then one file for 271. And then put all 3 of those files into the one. Yeah, the other folders are actually, their date is 2019, so I didn't update them at all. That's what's weird. Yeah, so just dump them all into 259. You'll be okay. Sorry about that. That was me being a little, I didn't want to update all 3 folders. So that's what that boiled down to, sorry. Okay. All right, so that's been updated in your D2L, so go check your quiz grades if you had emailed me about that. I've done it now, so yay. And we left off here, I think. We were working on 4.7, which is about flowchart thinking. We did the first 2 together, and I asked you to take a minute on your own and try to take a look at the third one. Zoom in on it. Okay. So here's our picture. We're given that it's a parallelogram, and it wants me to show that angle A is congruent to angle C. So did you guys do something here? Did you at least play with the picture? Get started on it? For instance, my first step is always look at the picture that they gave me. It's a parallelogram, but they don't have any markings on it. So I'd probably go ahead and put the markings just so that I can see them. So what do we know about a parallelogram?
Two pairs of parallel lines.
Okay, so I'll put the little chevron there for one set of parallel lines, and I'll put the double chevron there for the two sets of parallel lines. I like it. Okay, so I just want to make sure that I've got that picture in my brain of what's going on.
We also know, because it is a parallelogram, that the two consecutive angles are supplementary.
Okay, so like A plus D is 180, D plus C is 180, C plus B is 180, okay. That's one of our properties that we have.
Another part of the definition is that opposite angles or not opposite sides are going to be congruent.
Okay, one of the properties that we found was that those opposite sides are going to be congruent. Yeah, so we know that, so we might use that as we go along. It's probably part of what they're going to do. As a matter of fact, as I look here, I see, as I'm looking at the way that they set out their proof, first they establish we have a parallelogram, right? And then they're starting to talk about parallel sides, it looks like, and that's going to be part of one of those properties. It's like definition of a parallelogram. And then here, it looks like they've got three things. What do you suppose they're trying to do with those three things? Yeah, they're trying to get to some kind of triangle congruency, right? And the only hint that I have there is the middle guy is same segment. So if I have segments, well, there's different ones that I could have. It could be angle, angle, side, because it could just be one segment, right? It could be side, angle, side, or it could be side, 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 right? Because side, side, angle isn't one, so we don't use that one. And angle, angle, angle isn't one. Am I missing one? Angle, side, angle, but that goes with this one, right?
It's kind of cut off. I don't know if the people on Zoom can see it.
Oh, sorry guys. There you go. Okay, so those are kind of the congruencies we're probably looking at because they said same segment. Which one do you think that they're talking about when they say it's the same segment? The diagonal, right? DB, because that's shared between these two triangles. So we kind of need to get a feel for what they're doing. They're comparing these two triangles. They're trying to set them up as congruent. We know that that's what they're after. We've got this guy right here. So what could I say there?
Side DB is congruent to side BD.
DB is congruent to BD. I like it. So that gives me one of my sides. Okay. So we'll have to think about which one of those we want. Angle, angle, side, side, angle, side, 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 side. There's actually different ways you could go about doing this, so I'm not necessarily tied to one. Let's go start from the beginning. ABCD is a parallelogram. How do they know that? Given. It's almost always your very first step, guys, whatever they gave you. AB is parallel to CD. That's from the definition of a parallelogram. So they're building on what they already have. Okay. What do you suppose the next thing is that happens from the definition of the parallelogram? Okay, good. BD, no. AD, thank you. Sorry. I was like, nope, that's not one. It's parallel to BC. There we go. And that's also because of definition, right? These two things automatically happen whenever we have a parallelogram. Okay. Now, once we've established those, we already showed where we can prove all these other properties, right? But where's Drew Cunningham? Missing somebody?
Is he on the roll sheet?
Oop.
last name familiar?
Nope.
Yeah.
Sorry, Drew. We don't know yet. Hopefully, if it's one of our students, they'll change the name and log back in, right? I only do that because one of our faculty members had somebody trying to log into their Zoom that was like a bad name on the thing and like trying to harass her basically. So she ended up having to put in passwords and stuff. It was crazy. Yeah.
Gabriel Cunningham's in this class.
Yes, so we're not dealing with that, right? Okay, no Drew Cunninghams. All right, let's see. So what do we want to do? Here's our picture. For sure, we want to use this middle line as a side, being congruent. What properties do we have? We have two parallel lines.
The property that she mentioned was
Okay, opposite sides are congruent, so what would that give me? Like, okay, A, B, and C, D, I heard. Those are going to be congruent because they're, okay. So we could do A, B is congruent to C, D. What was that conjecture? On your list, it's under parallelograms. It's probably going to be something about opposite sides. Parallelogram, opposite sides conjecture. That it? Okay. If you just string enough words together, you'll probably get there. Parallelogram, opposite sides conjecture. It's in your word bank, so look there. Yeah, Ryan, so we're headed for a triangle congruency. Which one do you think we're after? We got a side and another side. Oh, let's do the third side. Sure. This guy over here with this guy over here. Same reason, right? AD is congruent to BC. Also because of parallelogram. There's not enough room here for me to write it. Opposite sides conjecture. So what do we think?
triangle ADB is congruent to triangle CBD.
Good. Okay, so make sure you name them in the right order, right? So she said A, B, D. So she went across the 1 hash mark to the 3 hash mark. So when she went and named it the other triangle, she said, I'm gonna put it right here. She started across the 1 to the 3 and she said C, D, B. That's the only kind of tricky part in this, is make sure that when you name your congruent triangles, you name them in the same order so that corresponding parts line up. That's really important. And we said that's because of the side, side, side triangle congruency. I like it. You think we're done? They're congruent.
And then we say that angle A is congruent to angle C because of CPC.
Right. There's clearly one extra step they want me to do, right? And it's always whatever they told you to show. So angle A is congruent to angle C, and Miss Summers said that's because of CP, CTC. Congruent, or I'm sorry, corresponding parts of congruent triangles are congruent. Okay. Now, we did this side, 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 because that's what we saw first. And we had the mention of the opposite sides being congruent, so hey, why not use it? But we didn't have to do side, 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 okay? For instance, I could have used one of those opposite sides, like say this one on the top, the CD to the AB, one of those, and I could have used the diagonal in the middle as a side, and then I could have picked up this angle here, this little angle at D and this little angle at B, that would have given me side, angle, side, and side, angle, side. And I could have gotten that angle because those are parallel lines and those are alternate interior, okay? So we would have been okay. Does everybody see what I mean here to here? You could have done that. The only thing you can't do at this point is you can't use A and C because those are the ones I'm trying to prove. I also probably could have figured out the opposite angle
We also do angle side.
Yeah. This one here with that one there, because those are also alternate interiors on the other side of parallel line, set of parallel lines. And then I could have had, it would have been angle, side, angle, right, if I used the diagonal. Yeah. If you use this side, for instance, then you could have had angle, angle, side for sure. So you could have done any of them. It just depends on which way you picked them out. Yes, ma'am.
You said we can't use angle A congruent to angle C, but because of the property that both pairs of opposite angles are congruent, couldn't we use that? Is that not a?
Except for they're trying to make me prove it.
Oh,
Yeah.
gotcha.
That's what they're trying to make me show. So if I was showing something else, like those opposite sides are congruent, then I could use the opposite angle parallelogram, opposite angle congruency conjecture. Yes, I could use it. So it's just whatever they're trying to make you show, you can't assume that. You have to get that as your last step. Yeah, absolutely. But we could have done the alternate interior, guys, right? And then we would have had like angle, side, angle, and that kind of thing. Absolutely. Just can't use A and C right now. It's all right? Is that kind of what you did? Did you do that before? Were you stuck? Or everybody's golden with flowcharts?
I feel like I'm gonna like them more than the paragraphs.
Nobody seems to like paragraph. It's funny.
So much writing. If your hand hurts at the end of it.
It is, and it's funny because whenever I used to teach high school kids and stuff, they never wanted to do the 2-column proof. They always wanted to write it out like paragraph form, and I'm like, okay, fine. To me, it's a lot of work, but fine, because you have to make full, complete sentences or whatever. But when I started teaching this class, college kids, y'all always want to, like, I don't want to do the paragraph, you know, let's do a faster one. And so, like, the last couple of years I've taught this class, almost everybody, when I give them a choice on a test of what kind of proof they want to do, they almost always do the 2-column. And I'm like, I mean, it's more mathy, it's more scientific, so I'm fine with it, but it's kind of funny the way that different people see different things.
I also just feel like because it's kind of like guiding you through it, like you have to see it through the way that they already set it up for you.
Yeah.
But because it guides you through it, it's easier to draw a paragraph off of that than coming it from, I guess, like doing it on your own.
Mm-hmm. Well, and this is nice, even though, like, you have to make sure you're doing their thought process. You have to follow them. So if you get lost on their thought process, it's kind of your duty. But at least gives you kind of a hint and a direction, right? Like, you can see from here, oh, they're doing 3 things, and then there's this. That's probably a triangle congruency, right? And plus the other 2 had that in there, the triangle congruency. So absolutely. At least it gives you a little bit of insight where to go. Starts you out. Sometimes starting a proof is the hardest step, like getting it going. So, all right. So I had said to finish that one out and then to go to 5.7, proving quadrilateral proofs, which I did, or properties, which I did get up there. Which actually some of this is more of what we were doing just now, because that last problem, for instance, was a parallelogram property, right? So it's a quadrilateral property, so we're proving them. But they're looking for different things. So did you start on these? Did you have questions about these? If you want to, these are a little harder. Notice I didn't make this due, right? It's not an assignment. This is a little harder because this one's giving you the flow chart, but then when you look at 2, 3, and 4, they're not giving you the flow chart. So that's a little bit, they want you to do a flow chart proof basically from scratch, right? I'm not going to require you to do that on a test. I'll always give you the outline, so to speak, but they're trying to get you to kind of think, what would my steps be? So what would I do for dart A, B, C, D, by the way? This figure, this chevron thing has a name. It's called a dart.
You start by marking what it's given you, that line A, B, and B, C are congruent.
Okay, that's congruency. So A, B, and B, C. And then we also have C, D, and A, D. Okay. So this is some weird quadrilaterally thing. It's concave. It's certainly one that we haven't seen before, right? We don't know anything about its properties at all. But what they're trying to tell us, well, let me look at the picture first. When I look at the picture, what I see is that they've got one of the diagonals drawn in here. It's the one that happens to be the interior diagonal. The other diagonal, notice, is on the outside. And that's why we know it's concave, because it's folded in on itself like that. One of the diagonals has to be outside. But looking at it like this, I'm thinking, okay, they're trying to tell me something about what a dart looks like, okay, and what some of its properties are. So they're telling me angle A here and angle C are congruent. That's what I'm supposed to show.
We also know that DB is congruent to BD because they're sharing that side. Then we have triangle congruency side, side, side. So we know that because of
Yeah, great. So, and I see that from Demondre too. We've got the same segment in the middle. Okay, good job, guys. So that guy's congruent to itself. And so we kind of see we're going to have a side, side, side. So those two triangles are going to be congruent. I'm sorry, Elijah, I don't know what you mean by scissor truss. Probably something that I should know, but I don't know that. I could definitely do a patty paper proof here, right? We could just fold it right there on the, on what looks like it was its reflection, line of reflection here, and put it on top of each other. Okay, well, we'll keep going, we'll see. Okay, so now we've got this two triangles congruent to each other, and then we would say what?
we know that angles A are congruent to angle C because of CP.
CPCTC. So let's see how that particular flow chart's going to look. We haven't created one, so I just want to do this one from scratch, and then you can play with it and see the other ones if you want to. So what did we start out with? We started, yeah, marking the congruencies, right, on our picture. So whenever I started out, there were two things that were given. Does everybody agree? So if I was making a flow chart, and by the way, your flow chart doesn't have to look exactly like my flow chart, because everybody does just a little bit different. But if I was starting out, I would have two rectangles with lines underneath them. And those two rectangles for me represent the given stuff. Does that make sense? Okay, so what would we put in the first box?
Side AB is congruent to BC.
Good. AB is congruent to BC. And my reason for that was given. But we were also given something else, right?
Side CD is congruent to AD.
Good. Okay, CD is congruent to AD, also given. That's still my reason. And then I'd pull those together, or actually, I'm gonna put a third box. Is that okay? I'm gonna put the third box right here. Boom. It's gonna be really succinct. It'll be nice. What's the third thing y'all told me?
The same segment, DB is congruent to BD.
DD is congruent to DB. And that was somebody, a couple of people told me, same segment. Right? Okay, so now I've got these three lovely pieces of information together, and I'm going to do the little arrowy thing that they've been doing. We're going to stick all those together to come up with one big box here. Okay, so then what did y'all do next?
You can say triangle ABD is congruent to CBD.
Okay, triangle ABD is congruent to triangle CBD. Again, making sure that those parts line up, right? And the reason we have that?
Side angle congruency, triangle congruency.
Side, 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 triangle congruency. Awesome. And then one more step, really, right? It's not a very long one.
A is congruent to angle C.
Because that's what they wanted me to show, right? Angle A is congruent to, angle C. That's terrible. That's angle C, honest guys.
And that's because of CPCTC.
And the reason for that is CPCTC. Very nice. Okay, so for something like that, we didn't do a lot of work, right? Y'all kind of played with the picture a little, you looked at it, you thought it through, and then we put together the triangle. Probably, to me, it's still easier on that one to do a 2-column proof because we just go boom, 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 here's our reasons and stick it all together. But they're asking for the flow chart. So that's not hard to create that one. Sometimes they can be a lot more complicated, so just be aware of that. Oops, again.
Which one's the 2-column?
We haven't done it yet,
Okay.
so we'll see that in a second. Hold that thought.
You keep saying them. I think I remember doing them, and I don't think I like them.
Oh man.
I just don't like.
And it's really sometimes a personal preference, you know? And that's why I said when I taught it for high school kids, they were like, I don't like this 2-column proof. It's difficult for me to work with. I'd much rather just write the sentences out. So if you'd rather write a paragraph proof, now I will say you have to learn all 3 because on a test I'll have one of each, but there will be some that just say use your own method, whatever you want. And for that one, you can use whatever you like.
And we have to be able to teach all 3 too.
Say
So we have
again?
to be able to teach all 3 for them, like our kids are prepared.
Yeah, so are you middle school or high school?
I want to do middle school.
Middle school. Middle school probably won't do 2 columns. So if they're rough on you, it's okay. That might be, you know, that you're zooming in on the kinds of kids that you're going to teach, and they are a little bit more difficult for middle school kids. So that might be perfectly okay. So don't stress out too much yet. You'll be all right. Is everybody in Zoomville okay? Not getting many messages over there. Yes, okay. All right, so this guy, 5.7, you're not gonna have to turn it in, but I would like it if you would play with it and do some stuff with it. Feel as comfortable as possible with those. And we'll go from there. The reason we're not gonna turn that in, oh, by the way, let me go ahead and throw this out there. I told you on Tuesday on the back side, thank you guys for your feedback, I appreciate that. 4.7 on the back. There's 13.2, which is called planning a geometry proof. And it's a lot of the same kind of stuff, but notice that they are like, oh, you can do either one. So they want you to work through, and some of these are like parallel lines and stuff like that. I put that on there so you can see it. So you can see the kinds of stuff that they might want you to do. But we're actually going to prove the other stuff, and that's what I want to focus on, because you're going to have to turn in the other one. This one, play with it. Again, look at it. If you have problems, go see me. It's not going to be to turn in, so I'm not too stressed out about it. But it's more opportunities for you to practice proofs. And like I said on Tuesday, you just have to do proofs to get good at doing proofs. Just have to do them. The more you do them, the better you get at it. That's my philosophy, at least.
So of these 3, what are we turning into?
You're going to turn in this page. Special angles on parallel line proofs. Okay. You're going to have some time to work on it. More than a week even, because I want you to work on it and work on it and work on it some more. Some people will be like, boom, 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 I did those, that's pretty easy, I'm okay. And some people will struggle. So today we're gonna do several of them, and I want to work through it with you so you can see both directions basically. But then you'll have to do some others on your own, okay? So here we go. First one. Actually, is the triangle one on there? No. The first one I want to do, because I think that this will help us out before we get to the special angle proofs. The first one I want to do is for the triangle sum, okay? So you guys remind me what the triangle sum theory or conjecture says. the sum, oh, that's the inequality. I want the interior angle.
Are equal to 180.
Okay, the sum of the interior angles of a triangle adds up to 180 degrees, something like that. I shouldn't have said sums and adds up to, but that's okay. I double said sum it up. Okay. When I add up the interior angles of a triangle, the sum is always 180 degrees. And you guys have been using this left and right and just going with it. And you told me on day one this was a thing that you knew. Nobody ever questions it, right? But technically in geometry, you can't not question it until you've proven it. So we're going to prove it so that we can use it. And we all know that it is, but we're going to see how one of these might work. So for instance, I'm just given a statement here and I'm told prove it. Prove this, which is what your homework is going to say. Okay, here it is. It says prove the vertical angle theorem. Two angles are vertical angles and they are congruent. So we're going to prove that stuff. Okay, so you're just given a statement. There's no picture. There's no nothing. And you're just thrown to the wolves. So I will say in Dr. Webster world, it is always best if you can to draw a picture first. The picture helps us. Did you see how all those pictures helped us on the dark one? Oh, just do, we're done. So draw a picture. So what we need to think about is what do we know and what are we trying to prove? We're trying to prove something about this sum of the interior angles, right? The only thing we actually know here is we have a triangle. Does that make sense? So we need a triangle. What should we call our triangle?
ABC.
ABC. I like the way you think. Okay. All right. So the idea on this particular proof is we're going to be given ABC is a triangle, and we're going to prove the measure of angle A plus the measure of angle B, plus the measure of angle C is 180 degrees. That's what we're trying to prove, right? Or show. They would use the word show. If you don't like using the measure of angle 1A, you could put little 1, 2, and 3 in there and use one like up here, 1, 2, 3, the way we've numbered our angles in the past. That would be fine. Okay. So here's what we're going to do. We are going to talk about the exterior angles. And what do we know about those stinking exterior angles? Okay, the sum of the exterior angles is 360. Let me go ahead and put in 1, 2, 3. And then on the exteriors, I'm going to call them 4, 5, and 6. Is that okay? 4 on the A guy, 5 on the B guy, and 6 on the C guy. Okay, Demondre says exterior angles add up to 360 degrees. Yep. So I'm compiling things in my head. I know that measure of angle 4 plus measure of angle 5, I'm not putting this in my proof, plus measure of angle 6 is 360 degrees. That's what you guys just told me. I'm not putting it in my proof yet. We might use it. But what else do I know about exterior angles?
angle 4 is equal to angle 2 plus 3.
Okay, so I know stuff like the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3. Does everybody agree? This outside guy out here is equal to these two guys here. And there's one more thing I know about them. Like, talk to me about 3 and 6. Elijah says, each angle forms a collinear pair of supplemental angles. Exactly. 3 and 6 is 180 degrees, right? So measure of angle 3 plus measure of angle 6 equals 180 degrees. Oops.
And same thing for 1 and 4.
Same thing for 1 and 4, exactly. So let me put that up there real fast because we might need one of the others, if that makes sense. So the other one is measure of angle 1 plus measure of angle 4, 180, and measure of angle 2, measure of angle 5 is 180. Okay. And the same thing, by the way, I only put the 4 guy here is equal to 2 plus 3, but we also know the 5 guy is equal to 1 plus 3, the 6 guy is equal to 1 plus 2. Okay, so we've got a lot of little factoids running around there. Excuse me. Which of them would we like to play with? Remembering that my ultimate, let me make a slight edit here. My ultimate goal is to show that 1 plus 2 plus 3 is 180, right? Because I got rid of that A, B, C bit because it was, I had double angles at A, so I wanted to make sure we were talking about the correct angle at A. So that's my ultimate goal. I want those to add up to 180. There's actually 3 or 4 ways to do this, by the way, so. So if you don't do it exactly the way we do it, it's okay. I actually see 2 statements in this list of stuff you guys just gave me that can do it for me.
Could we use substitution of the measure of angle 4 equals 2 plus 3, and then plug that in for the measure of angle 1 plus the measure of angle 4 equals 180?
That's the ones that I saw. Again, you can do it lots of different ways, but that's the ones that are just sitting here in the list that are glaring at me. Look, we have angle 4 is the same as angle 2 plus 3, and we have angle 1 plus angle 4 is the same as 180. Okay, so if we put those together, then we can substitute out angle 4 for 2 plus 3 and we'll have it, right? Okay, so we're going to have to get there. We're going to have to do a formal 2-column proof, but I like using those 2 pieces of information in my proof. There's other ways to go. So for instance, if you guys wanted to go with this 360 guy, then you could totally do something about the exterior angles adding up to 360. And then you could substitute out for some of the interior guys with the exterior guys, and then it would subtract out and you'd end up with 180. So it would be fine. There's lots of ways to do this. This is just the one I see right this second. Okay, so let's start our proof. We need a statement and we need a reason. And that's why it's called a 2-column proof. 1 column has the statements we're trying to make. 1 column has the reason that we are able to say that thing. You've always got to justify yourself when you're doing proofs. Always, always, always. And what did we see with the flow charts? What did they always start with? Given. The only thing we know is triangle. This is a triangle, right? ABC is a triangle. Okay. And that's because it's given. That's where we started. Okay. Now, we have to talk about We can't just start talking about angle 4 because that wasn't given to us, right? So we're going to talk about angle 1, 2, and 3. We're going to talk about angle 4, 5, and 6. And then we'll make these statements and make some substitution. So what do we want to say? Let me continue this. ABC is a triangle with angles given as 1, 2, and 3. Let's just get that out there. Angle 1, angle 2, angle 3. That way we'll mark that in the given. That's fine. So we're just naming angles in the triangle. We didn't do anything special, right? Okay, how does that help me? We'll talk about angle 4, right? Why are we able to draw this thing up here and label it and call it angle 4 and talk about it? Ah, extend the segment. That's what we did, right? So we will construct or extend. Oh, not angle. AC to create an exterior angle, angle 4. How are you able to do that? We're just using a definition there, right? We know that an exterior angle is the supplementary angle that's created by extending that segment. And so we're just calling it the definition of an exterior angle. We're using that definition to create an angle 4 up there that we wanted, right? Okay, so that's definition of exterior angles. Okay, now there's some other ways you could do that. You could have said, I'm going to construct this segment, or I'm going to do this, or I'm going to do that. And those are all in your word list there. You can always extend something, draw the line farther, that kind of thing. So that's not this is not the only way you could get there, is what I'm saying. Okay, I got angle 4. Now what?
Supplementary, saying that 1 and 4 are supplementary to each other.
Okay.
I just don't know the official reason.
So what we want to start with, I'm hearing from Ashley what she wants to start with, and we're going to go that way because she's the first one to yell, is that measure of angle 1 plus the measure of angle 4 equals 180 degrees. And she just doesn't know what her reason is.
It's 180 degrees.
Okay, so it's a linear pair of angles, right? Okay, so definition of linear pair, absolutely. It's like, we know we can, we just got to be able to cite the reason. Absolutely. A linear pair, we know that they add up to 180 degrees. Absolutely.
So if we were trying to prove that three different things added up to 180, what would be worded definition of supplementary angle?
You probably called them 3 supplementary angles or something like that. Yeah, it's just because they're 2, it gets that special name. But that is a good point. You don't have to have 2 angles to be supplementary. Supplementary just means angles add up to 180 degrees. Normally it's a pair, but not always.
Sorry, go ahead.
Would it be the linear angle postulate or definition of linear pair? I'm just looking at the word bank.
Well, we could probably add in an extra statement if we wanted to and say angle 1 and angle 4 are supplementary, or angle 1 and angle 4 are a linear pair or something like that, and call that definition of a linear pair. And then if you wanted to say, like here, we've got the measurements adding up. If you want to, you could say, what was it? Linear pair postulate. Yeah, so you could get more in depth here if you wanted to, absolutely. And sometimes, like some books, you'll see they're like even more sticklery than I am about that stuff. So she's saying in the word bank, it's for linear pair postulate.
But you didn't know if the definition and the postulate were the same thing.
They're not the same thing. Linear pair is literally these two are a linear pair. So you're right. I actually technically need that little supplementary piece in there. So it's good for me to throw that in. That's good.
And I have this question from the other day. I think it came up on one of the assignments from the book. In order to call them a linear pair, they have to be attached to each other. So
Yeah.
for instance-
So the linear pair has to have a vertex and a side in common. Okay. So here we've got, it's actually backwards, sorry. 1 and 4, right? 4 is the bigger one. So that's what we've got going on. So they share that vertex and they share that side. So we can call them linear pair. If it just looked somewhere in the picture like this, we could call them supplemental, but we can't call them a linear pair. And this happens a lot whenever you're doing something with the parallel lines. Like we have those parallelograms and we said, it's not subsequent, consecutive. I'm like, consecutive angles are supplementary because we know they're not touching, they're not sharing an angle. So that comes up a lot for something like that.
I think that's what it was. It was the angles of a parallelogram or something.
Yeah. So like if we were here, let me go this way, in a parallelogram, you know, then we know 1 and 4 are supplemental to each other because they're consecutive, but they're not a linear pair at all. Yep, that's the difference. Good questions. I like them. Okay, so we've got those two adding up to 180. Now what?
We got exterior angle conjunction.
We know that the measure of angle 4 is equal to the measure of angle 2 plus the measure of angle 3, and that is the exterior angle conjecture, which says that the exterior angle on one of your angles of the triangle is equal to the measure of the interior, the other 2 interior angles, right? Okay. We're almost there. And I think once you start working with these and you see the way they kind of go, then it becomes, oh, okay, I feel the flow of it and I know where I'm headed. And a lot of times it does turn out to be what Ashley's saying, I just need the reason. You know, so you're scanning through the word bank trying to find something that matches with, you know where you're headed, you just need to know what it's called. That's what it boils down to.
I feel like that's why I didn't like them in high school, because I could never come up with the correct, proper reason. It's just like, yes, I didn't.
I see it. I know the reason. It's there. Yeah. So you just got to put the right word in the right place, unfortunately. All right. So now we're there, right? What do we want to do? There's actually 2 ways I can do this. I can substitute out just flat. Oh, actually, there's not 2 ways because they're not equal to the same thing. So, well, you could, if you wanted to, you could solve this guy for angle 4, okay, and then set them equal to each other and use the transitive property. So that would be like 180 degrees minus measure of angle 1 equals measure of angle 4 equals measure of angle 2 plus measure angle 3, right? And then using the transitive property, you dump the 180 out of the middle and you say, you dump the angle 4 out of the middle and you say 180 minus measure of angle 1 equals measure of angle 2 plus 3. And then you'd move the measure of angle 1 over, and then because you can do addition property of equality, and then you'd have 180 equals 1 plus 2 plus 3. So you could do it that way. That's probably the hard way to go about doing it, but I've seen people that really like to use the transitive property, so that's the way they do it. Here, because I have this guy, angle 4, measure of angle 4 set by itself, I know what it's equal to, so I have a value for that guy. So I can just use the substitution property, which is what Ms. Summers said. Okay, so I can literally pick this up and stick it in up there and substitute. That's what it's called. So that's what we're gonna do, because that's what she told me. What I have then, whenever I do that substitution, is measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees, and we're gonna just say substitution property. If you want to, you can say substitution property inequality or that kind of thing, but it's just literally a substitution property. Okay, are we done? Since I made that little edit, 1, 2, and 3, we actually are done, right? So I'm happy with that. What I would like to do at the end, though, is to come back and say, therefore, we know that the interior angles of a triangle add up to 180 degrees. I like for you to come back and throw in a little statement at the end that tells me that you know that you've achieved your goal, okay? The easiest way to do that is kind of restate what the property was or whatever the postulate is that you're trying to prove. There was a mathematician once upon a time, it's kind of famous, who always signed all of his proofs at the end, QED. So whenever he finished a proof, he'd just write QED, and that lets you know he was finished. And the QED stands for quite eloquently done. Is that not pompous? That's pompous, right? But that's the way he would do it. He'd be like, I'm done. Do QED, quite eloquently done. It just lets everybody know he's done. There are certain like little notations that you see sometimes. They'll do a little thing like that or something. So I don't care which way you do it. Well, I do care. I prefer the little statement that says, I know that all the interior angles of a triangle add up to 180 degrees because dang it, I just proved it. I did what I was supposed to do. Yes, ma'am.
Will any of these not be able to be proven? Okay.
They are all provable. And I actually have the proofs of all of them. I know, it's crazy. That's crazy. Now, some of them you might prove differently than I do, and that's okay too. But they all have at least one proof. Okay. See how a two-column proof looks different than, like, say, even a paragraph where we write it, or definitely different than the flowchart, right? And the really big problem most people have with the two-column proof is there's no direction. The flowchart kind of helps me out a little bit, but I have no direction for these. Two vertical angles. I think y'all will like that proof. It's the first one on the list. I did not put a date on it yet, Miss Mary. Actually, I think in your T2L, I might have put a date on it. Y'all's test is October 8th. So I want this in on the Tuesday before. So let's say do October 6th. That way you're not stressing about proofs and tests at the same time. Okay, so that gives you about a week and a half to work on this. And I'm not intending to give you any fresh homework because we're working on proofs right now. So this is what you should be focusing on. And I will say, same thing for this that I mentioned, I think a week or so ago. If you get in there and you're just stuck on the alternate exterior angle theorem and you can't prove that one, don't beat your head against the wall for an hour and a half with that one proof, right? Look at it for maybe 5-10 minutes, let your mind think about it. And then when you finish and you're like, okay, I can't do that, go to the next one or go to the next one. Don't just stare at that same proof and be unhappy with yourself, right? So sometimes going to a different proof will help you, oh, that I should have used that back there on that other one. Or get help, you know, phone a friend. There's no especially in proof time. There is no problem, no indignity with getting help from a friend. Okay, so let's say Tuesday the 6th. All right. There are 12 of them. That's about 10 days from now, right? The 7 plus 5, 12. Oh, it's 12 days from now. So you need to do at least one proof every day between now and October 6th, and you'll be good. But don't put them all off until October 5th, because then you'll be struggling. Do you want to use a 2-column proof, or can we use a flow chart or a paragraph proof? I don't care. That is a really good question. So on these, it's really whatever is more comfortable with for you. I will say, even though you feel comfortable with flow charts, you may not feel comfortable creating them from scratch. So most people don't just create a flow chart proof for no reason. So probably I would bet most of you will stick to a paragraph or a 2-column. But if you want to make a flow chart out of it, I am happy with any of them, as long as you are making logical step-by-step progress. That's what I need. This is all that very deductive reasoning, right? Okay. Does that answer everybody's questions? I think so. I don't see anything new in the chat. All right, good. Okay, so let's talk about vertical angles theorem. The vertical angles theorem says if 2 angles are vertical angles, then they are congruent. Okay. What's given there?
2 parallel lines and transversal.
Oh,
Sorry.
I don't have to have parallel lines for vertical angles. I need what? Intersecting lines. So hold that thought, because I do need, for number 2, parallel lines with a transversal, right? So what I need here is intersecting lines, because vertical angles are created when 2 lines intersect, and they're the ones that are opposite from each other, right? So let me label these on top 1, and then 2 and 3 side by side, and 4 at the bottom. So I'm given, it says, if 2 angles are vertical angles, then they are congruent. So pick a pair of vertical angles. I don't care which one.
Does it matter if we say like angle 1 is congruent to angle 4, or measurement of angle 1 is congruent to measurement of angle 4?
So they're actually saying congruent. So I need that's the show. That's the show step, right? So you want to do 1 and 4? I don't care. Okay, so they want me to show angle 1 is congruent to angle 4. Maria picked it, 1 and 4. It's all her fault if we mess things up. Oh,
Don't do that.
I'm kidding. I'm totally teasing you. Sorry. So we want to show 1 is congruent to 4, right? Hold on, Ryan. We'll get there. You're correct. I like it. I like your thought process. I need a given. What were we given? It says, if 2 angles are vertical angles, then they are congruent. These are vertical angles. That's what we're given, right? You have a set of vertical angles, basically, okay? And I'm going to be so bold as to say angle 1 and angle 4 are vertical angles. Okay, that's what they're giving me. They didn't actually say 1 and 4, but they did say you have a pair of vertical angles. If you would like to add an extra step in there, you could just say the given is you have a set of vertical angles, and then you could draw your picture, and then you could say angle 1 and angle 4 are vertical angles because of what? How do I know 1 and 4 are vertical angles? You guys are telling me they are. Well, other than given. So if they didn't give it to me, we would say it's the definition of vertical angles, right? Sometimes the definitions, I actually notice, mess people up more than anything else, because they'll be like, well, duh, we know 1 and 4 are vertical, you know, and it's just so ingrained. We know that they're vertical that we don't see. I need to say it's the definition, you know. So if I needed to put that extra step in there, I could. Okay?
Just gonna write because I know so.
Because I know it, man. Nope, that doesn't work. Dang it, that would be so helpful. Statement and reason. That's what Ashley said earlier. I know it is. I can see it. Oh, it's so frustrating sometimes because you're just like, what's the terminology you need there? That's the problem.
That's how you give us a word bank.
Will we have access to the word bank for the test?
No, I'll give you a copy.
Okay, good.
I do not expect you to memorize that kind of stuff. You need, like I said when I gave you that, you need to know what that means when we say, you know, vertical angle conjecture. You need to know that means, oh, those two are congruent. But, so you've got to have that background knowledge, but you don't have to come up with that name out of thin air. I always give you that. Okay, so I'm going to do first step is angle 1 and angle 4 are vertical angles. How do I know that?
Definition of
Okay, it's given or it's the definition of vertical angles. I like it. Good. And then Ryan gave me some clue as to which way I should go. He said, you need to go 1 and 3 and then 3 and 4. Now, I assumed that what he meant by that was I know something about 1 and 3 and I know something about 3 and 4.
Linear postulate.
Oh, that's it. Yes, we know that this guy plus this guy is 180 degrees because they're a linear pair. And we know that this guy plus this guy is 180 degrees because they're a linear pair. Okay, so that's what I'm getting from his comment there. So let's do, let's talk about, because Maria asked a second ago, congruent or measure equals. So in this one, the actual theorem says that the angles are congruent. So we know we want this one. But to prove it, I'm going to have to talk about them adding up to 180 degrees. And when I start talking about a number, I need to what? Anytime I have numbers actually in my angles, that's an equals, right? Okay, so I'm going to have to make a flip over here, so to speak. I'm going to have to start talking about measurements. Is that okay with everybody? All right, so the measurement of angle 1 plus the measurement of angle, oops, said it, but I didn't write it. The measurement of angle 3 equals 180 degrees. And I'm going to say what?
definition of linear pair.
It's actually the postulate, and the reason why the definition of the linear pair tells me what they are. They're two angles side by side. They share a vertex. They share a side. Okay, but and the postulate says that they add up to 180 degrees. Yeah, I like it. And then what? Okay, measure of angle 3 plus the measure of angle 4 is 180 degrees. Why do we know that? Linear pair postulate. You could do something like this and say they both have the same reason. That's fine. I've seen people do, for instance, and I'll do this sometimes myself if I'm just getting like lazy. I'll have this as a line and this as a line, and then I'll have both of those statements in there, and I'll just say linear pair postulate once. Yeah, yeah. But as long as you kind of delineate, this is this step and this is this step, it's fine. I do it sometimes whenever I feel like, I don't want to write that again. No worries. Okay, so how do those two help me? Yes, because we see, look at that. Excuse me, we're both equal to the same number. Because of that, I can set them equal to that number in the middle and each of them on the outside, right? So it looks like measure of angle 1 plus measure of angle 3 equals 180 degrees equals the measure of angle 3 plus the measure of angle 4. Okay. And notice we've kind of done some of this stuff before. We've just not formalized it, right? We've talked about it, we know, but we need to formalize it. So that's what we're doing here. All right, that's what, okay. Oh, and actually, shoot. I need another step below it. Sorry. So now because of that, I know what?
Measure of angle 1 plus the measure of angle 3 is equal to the measure of angle 3 plus the measure of angle 4.
Good. That I can drop out the 180 in the middle of it, and all of that's because of the transitive property. Sorry. Didn't complete my thought before I drew my line. Dang it. This is when I wish I was using erasable pens, but I'm so stinking expensive. Okay, so we're here. We're 1 plus 3 equals 3 plus 4, and we got like 2 steps left. What is it? What are we trying to prove again?
Angle 1 is congruent to angle 4.
Angle 1 is congruent to angle 4. So I see extra angle 3s in here.
Subtract it from one side.
And there's one on both sides, right? So I want to get rid of it off of both sides, so I heard subtract it. So subtract measure of angle 3 on both sides of the equation. That goes away, that goes away. I get measure of angle 1 equals measure of angle 4. How am I able to do that? Good, that's the subtraction property of equality.
Summer just has this word bank down.
Have you been studying that?
I'm a big algebra person, and so like all of the commutative properties and stuff, like they work in my brain. And
She's
so-
also got it right in front of her, so.
Yeah, the reason it's like
Yeah.
that stuff's algebra.
So yeah, this is an algebraic property, and pretty much anytime you see those equal signs in there and you start using stuff like that, like, oh, we can subtract something off of both sides of the same thing off both sides of the equation, that's an algebra property we've used, right? We're applying it here in this geometric setting, but it's that equality that's making it work. So it is an algebra property, that's true.
Mary asks.
Oh, Mary's got a question. Could you have done substitution property early and saved you 2 steps? If you had solved both of those for angle 3, yes, ma'am. Up here, y'all see it? So if she had said, I'm gonna make angle 3 equal 180 minus 1, and I'm gonna make angle 3 equal 180 minus 4. Y'all see that? Then she could have, no, hang on. That's still transitive. I'm still making them transitive. Oh, so I would have had to solve one of them for the 3, right? So if I had solved here, that's not going to give me concurrency. What did you want to do, Miss Mary? Done substitution.
We still have 1 step to go, right?
I'm not sure where you want to do the substitution, so. Never mind, it doesn't work. Oh, okay. It might be, yeah, it might be an equality thing versus a congruency thing. So, okay. It'll be all right. All right, so here we are. We've got measure of angle 1 equals measure of angle 4, but Maria says, I'm not done. I can't be finished yet. Why not? Yeah, we're still looking at equalities and not congruencies, right? Okay, these are measurements, and here we need a congruency. So that's just that fine little point that will cost you a point or 2 on a test if you don't get it out there. So instead of measurement equals, we want angle 1 is congruent to angle 4, and how do we know that those mean those? Definition of congruency. And again, that's one of those kind of things that's like a little bit like, well, duh, I know that. We know that if their measures are equal, that they are congruent. But we know that if their measures are equal, they are congruent because we know that definition, right? That's how we know it. Those are the same thing. They're not actually the exact same thing. They're just equivalent statements, right? They're not exact because this one's measurement and this is congruency. But they're equivalent because of the definition. You guys rock. It's awesome. So now we have vertical angle theorem. And by the way, that means you have your first, you can play with this, make it prettier, do whatever. But that is your first proof off of this assignment that's due in 12 days. So now you only have to do 11 proofs in 12 days. Oh. And we'll do 1 or 2 more in class on Tuesday. We're not going to spend forever doing these proofs because I want y'all to work on them. But in particular, I want to talk about a converse. I've mentioned Converse a couple of times. That's when I work it backwards, basically. Okay, instead of knowing I have parallel lines, so I get alternate interior angles, I start with alternate interior angles being congruent, and I prove that they're parallel. Okay, so it's like working backwards kind of thing. So we'll do 1 or 2 of those next week.
Today went by really fast for me.
I feel like it went by fast. I'm out of time, and I feel like, man, I didn't even call roll. So.
I feel like whenever we do the proofs, it feels like it takes so long to do it.
Sometimes,
Like 2 of them in class period.
yeah, some of them can be in depth, so then you're like, oh man, I didn't even get very much done.
So definitely do 1 a day.
Yeah, they can take some time. But just think, I mean, that's an hour basically. We did several flow charts and 2 full proofs, so that's not terrible. All right, if you're on Zoom World and I call your name, I have you on the attendance, you may leave. Everybody have a great weekend. I'm gonna stop the recording. If you have questions, hang around.